Let's see few problems in linked list. So first problem, detect a cycle in single linked list. Okay, there exists a list like this which has a cycle. We have to identify whether this list is ending with a null or cycle. Okay, generally we know single linked list always the last node contains null. So the question is to verify whether the last node of a linked list contains a null or does it contains a cycle. So detect a cycle in single linked list. Detect a cycle in single linked list. Very popular programming question. How we try to do this? How can you find out whether there is a, maybe there is a list like this, if I draw it here. Right, this is pointing to this node. So here there is a cycle, here there is a cycle. So this is 10, 20, 30 and 40. The last nodes next is pointing to 30 node. If this is the case, then there is a cycle in this. How do we detect the cycle in a single linked list? Okay, so there are multiple ways. What is the best way of finding out the cycle in a single linked list? So how do we actually create a list like this? How do we actually create, give an input like this? It is simple. You can have you insert 10, you insert at the end operation you do, insert at the end operation you do, insert 10, then insert 20, then insert 30. Okay, 3 elements over. Now once you insert 30, you hold its address. Actually this is head, right? This is head. Okay, so head next, its next will point to 30. Let that be temp. Let that be temp. So temp equal to head's next. This 30's address I am putting in temporary. Then keep adding the elements. Then keep adding 10, 20, 30, 40, 50 and 60. 60's next. Generally 60's next will be null. Instead of null, you write 60's next equal to temp. Means this will be created. This chain will be created. Like this, you can create give an input of this form. Now, how do we detect a cycle in the single linked list? How do we detect cycle in a single linked list? Right? So this is one important question. How to solve? Let us see the solution for this. I hope you understood how to create this list. Creation is very easy. You insert some elements like this and you hold the address of this in a temporary variable. Temp equal to head next. Suppose you want to store address of 4th element. I have 1, 2, 3, 4, 5, 6 and 7. From this is pointing to this location, for example. Okay, this way. So this is my head. So you can write, you can create temp equal to, you want this node's address, that is head hyphen next, its next and its next. So it will point to this location, temp. So when you insert the last node, its next you point it to the temp. That way you can assign a cycle is created. Now to detect, you have to write a code. You have to traverse the list and find out whether there is a cycle or not. So for this solution, one solution or the best solution could be using 2 pointers. Using 2 pointers. This is a very popular approach for giving solution to this. Based on this solution, there are so many problems. Like I mean to say, using this type of solution, you can give solution to many other problems in single linked list. That approach is using Floyd cycle finding algorithm. It is called Floyd cycle finding algorithm. So we know the game of rabbit and tortoise, right? You know they will be running in a race in a cycle, right? So if they are running in a circle, for example, right? So rabbit is here and tortoise will be here. Both will be starting. So rabbit will be running very fast. Tortoise is running at some slow speed. By the time rabbit reaches here, tortoise is somewhere here, right? Again rabbit will continue its second loop. By the time tortoise comes here, rabbit will come and meet it here. So, in this running process, in the running, no, in this cycle process, if both rabbit and tortoise meet at some point, it means there is a cycle. It means they are running in a cycle. See, if there is a straight road, okay, from 0 to 1 kilometer, for example, if rabbit and tortoise are going in a straight line, they can never meet. Tortoise is here, rabbit is here. By the time rabbit reaches this location, tortoise will be here only, right? They cannot meet. If they are running in a cycle, in a ground, if they are running in a ground in a cycle format, both are here. By the time tortoise reaches here, rabbit will go one round and come back again here. So there is a chance they are meeting at some point. If they are meeting at some point again, means they are running in a cycle. That is the main underlying logic behind this Floyd cycle finding algorithm. Okay, very popular technique which is used to solve many problems in problem solving or in general programming or placement level questions. Okay, I hope you understood the rabbit and tortoise approach. If they are meeting again at some point when they are running, it means they are in a cycle. So using that logic, we will try to find out whether there is a cycle in this or not. How we can do that? See the solution. Okay, I will take 2 pointers. First one is slow pointer, second one is fast pointer. Why? Tortoise runs very slow and rabbit runs faster. Okay, now the approach here is that let them both be here, that is slow pointer and fast pointer, FP and SP. Okay, you check if this is not null. If this is not null, you move your fast pointer to 2 steps. So let this become your fast pointer and let this become your slow pointer. So fast pointer will move 2 locations, fast pointer next, FP equal to FP next, and slow pointer equal to slow pointers next. So after first iteration, my slow is here and fast is here. Now one more time I will iterate this. How will I iterate this again? Second time, what will happen? Your FP will come here. And your slow pointer will move here. SP. Now again iterate. Keep repeating this process. FP from here will jump to this location. Your FP will come here. Okay. And where is your slow pointer? Your slow pointer comes here, this way. So I am erasing this. Again iterate. Where will your FP come? FP will come back here again, and your slow pointer will come here. Okay, like this. So next what will happen? This is also gone, right? Yeah. Again the next iteration, your FP will come here, and your SP will come here. Okay, your FP will come here and your slow pointer will come here. Here is your slow pointer now and here is your fast pointer. After this what I will do? Next iteration, where will your FP come? Your FP will come here and your SP also will come here. Okay, so after few iterations, your slow pointer and fast pointer are meeting at some point. When they are meeting at some point means it is clear that there is a cycle. They both are running in a cycle. This is the logic of detecting a cycle. Same logic of fast pointer, slow pointer will be used in so many other problems. Okay, we will see one by one these problems. I hope the logic is clear for you, right? It is very simple. Take 2 pointers, slow pointer and fast pointer. Let slow jump 1 by 1 and fast jump 2 by 2. Slow jump 1 by 1 and fast jump 2 by 2. 2 steps each. Okay, if at any point they are meeting, confirm, say break the logic and say yes, there is a cycle. Okay, there is a cycle, right? Definitely, if that list contains cycle, it will break at some point. If it does not contain, no. Suppose there is a, let us take a simple example like this. If I have a list which does not have a cycle, for example. Okay, so this is pointing So we are taking 2 pointers, no, a slow pointer and a fast pointer. After iteration 1, what will happen? This is your fast pointer, this is your slow pointer. After iteration 2, this is your fast pointer and this is your slow pointer, right. If at any point of time either this slow or fast has a null, it means it has no list. Directly you can say, if the fast pointer's next part, if the fast pointer's next part is containing null, we can simply confirm that there is no cycle in that, because in a cycle there is no chance of null anywhere. There is no chance of null anywhere. So what is your condition check here? Condition check here is that if while your fast pointer's next is not equal to null, okay, then you repeat this process. In this while loop, if at any point your SP is equal to FP, you will say cycle exists. Okay. So this is the logic for detecting a cycle in single linked list. Okay. So how do you write the logic? We will assume that the linked list is already created. And we will try to write the logic. I will just write the while loop part only. Okay. So let me write a function void. I will just write it theoretically here. We will implement it and see whether it is identifying the cycle or not. Okay. Void detect cycle. I am trying to do this. What I have to do, what is the first step here? Again, you assuming that there is a list already like this 10, 20, 30, 40, 50 and it is pointing to 30. This way if there is a list, right. What I should do? I should take 2 pointers. Okay. So struct node star what is that? One is SP and other is FP. Okay. Let both SP is equal to head, FP is equal to head. It means both are pointing to head node, right. That is what our understanding is. Here is your SP and here is your FP. Next, while condition. What is the while condition here? If FP of next is not equal to null, okay, or let's simply write FP of next. When it will break? It will break when it is finding null. What you have to do? When FP not FP of next, that's it, nothing else. If FP of next is null, it will that while loop will break. It will come out of the while loop. What I have to do here? SP is equal to SP next. And what is about FP fast pointer equal to FP of next. Okay. SP equal to SP next, FP equal to FP of next. So we are moving, slow pointer is going one step ahead and fast pointer is moving very faster, means two steps ahead. Now after doing this, I will continue the code here. If SP is equal to FP, after doing these two operations, if SP is equal to FP, you can break, you can write return here. We will take, because I want to know whether there is a cycle. So let me write here some integer. So return 1, else return 0. Okay. So it will keep repeating. If FP is equal to 1, this will return 1. This return 0 is not required by default. Let it be repeating. It is return 1. So if only this case is happening, it will return 1. Otherwise, it will be having 0. Okay. Now this is the simple logic. So this function detect cycle will give you, if it is giving 1, you will write in the main if detect cycle like this. Then you see out loop exist, else there is no loop in the linked list. Okay. I hope the solution is clear. It is very simple. Take 2 pointers slow and fast. Okay. Take 2 pointers slow and fast. So slow will jump 1 step, fast will jump 2 steps. The intuition here is that it is always believed that if the tortoise and the rabbit are running in a circle only, they can meet multiple times. Otherwise, if they are running in a straight line, they will never meet. So if they are meeting means there is a cycle in that. That is the logic of Floyd cycle finding algorithm. I hope this problem is clear. We will see the implementation after 2-3 problems. We will see first, then we will go for implementation of these problems. Let us theoretically understand problems and then we will go and implement them definitely. Next one. So the next problem is find middle of the linked list. Okay, find middle of the linked list. If there is a linked list like this, okay, if there is a linked list like this, you have to find out the middle. Even if it is even sized and odd size, we will talk about this case. But for understanding, let us assume the straight case, assuming it is an odd number of there are odd number of elements in the linked list. How do you find out the middle of the linked list? So here in this linked list, 3 is the middle element. Okay, even if I have even elements, even if I have even elements, you cannot have any middle element here, no. So that's why the base case or the safest case here is that assuming the given list is odd, what is the middle element in the list? Okay, if it is even, you may tell there are no middle element, or you can tell that 3 and 4 both are the middle element, that we can do. But let us see a simple and a straightforward case. Given a list like this, find out the middle element in the list. So let us take an example. I assume I have list like this. Okay, 7 is holding null. What is the middle element here? 4. Okay, what is the middle element here? 4. How do I get this middle element? Okay, how do I find out this middle element 4 or here middle element 3? If you see, what is the length of the list? The length of this list is 5. Okay, so where is the middle element actually? Actually it is at the half, no? After reaching half place, right? When I am coming till the half position, I am getting the middle element. 5 means 5 by 2 plus 1 if I do, I am getting middle element. 7 means 7 by 2 plus 1 if I do, I get the middle element. Because it is an odd number, we are assuming odd number case, right? So you have to reach 50%. You have to reach the, you have to traverse only the 50% of the list. Then you will get the middle element. How do I do this? How can I find out the middle element in the linked list? Again, for this we use the same standard approach what we have seen. How to do this? Again, take 2 pointers, same logic, slow pointer and fast pointer. Why? By the time fast pointer, see, slow pointer is jumping 1 step, fast pointer is jumping 2 steps, right? So see how it is working here. First iteration, what will happen? Slow pointer will come here at 2, fast pointer will come at 3. Next iteration, slow pointer will come here, fast pointer will come here. If the fast pointer reaches the last node, it is clear that the slow pointer will be pointing to the middle element. That is why, no, if it is going, it is jumping 1 step, it is jumping 2 steps. By the time this reaches 4, it will reach 8. By the time it reaches 4, it will reach 8. So we are coming almost to the middle of the list. Okay, same logic using 2 pointers, slow pointer and fast pointer. Always move this slow pointer 1 step and fast pointer 2 steps. Till when I should repeat this? Till the fast pointers contains null. The fast pointers next contains null. Till that you have to iterate. Once it is there, you stop. Whatever is the element at the slow pointer, simply print. Simply write cout yes slow pointers data. If you print this, it will give 3 as the answer. It means 3 is the middle element of the linked list. Okay. So how do we write logic for this? Again, we will try to take the case of slow pointer and fast pointer. We were talking about even and odd numbers, right? In case of odd number of nodes in the linked list, slow pointer will reach the middle node definitely like this. It will come here, slow pointer, and fast pointer is here. Okay. In case of even number of nodes like this, 1, 2, 3, 4, 5, 6. In this case, the slow pointer will reach the middle node when the fast pointer become null. It means it will come here, slow pointer will come here when the fast pointer reaches here, the last node. Okay, if it reaches here, the last node. For this see, your question is to print the middle element of the list. For that, the first step itself is to find out the length of the list. Find out the length of the list. Once you found it out, if it is odd number, then you write one if condition. If the length is odd, you write one logic. If it is even, you write another logic. Okay, to print the middle element. Right. So we will see what is the logic for this. Again, I will call a function the void print middle, some function void print middle. What I have to do here, I have to create two pointers as usual. So struct node star sp and star fp. Okay, and also I will write sp equal to fp equal to head, because they have to point to the starting pointer, that is head node. Next, what I have to do, I have to iterate in the while loop. While fp of next is not equal to null. While fp of next is not equal to null, what I have to do, jump the slow pointer one step ahead and jump the fast pointer two step ahead. So sp is equal to sp of next, and fp is equal to fp of next, like this. This will just you repeat this process. Whenever the fp next becomes null, it will stop the process. After this, inside this, simply write cout sp of data. This will print you the middle element. Okay, if you want to include that even logic, odd logic, you can just again write the logic of finding out the length of the list and do the process. Okay, so this is another important question, finding out the middle of the linked list. Let's go and see the next problem. Find the nth node from the end of the linked list. Find the nth node from the end of the linked list. What is this nth node from the end of the linked list? Suppose I have a list like this. Okay, 6 is holding null. Okay, I want the nth node from the end. I want the second node from the end. So this is the first node, this is the second node. So I want to print this 5. Okay, so that is the second node from the end. If I want third node from the end, I have to print 4. This is the third node from the end. Okay, how do we find it out? What is the solution for finding the nth node or kth node from the end? Okay, from the beginning it is easy. From the beginning, how do you find out the kth node from beginning? How do you find this out? You have a list. Okay, 1, 2, 3, 4, 5. Okay, I want the third node from the beginning. You want this node, you want to print the data in this third node. It is simple, write one while for loop. Using for loop, you can iterate. For I equal to 0, I less than k, I plus plus. So first time, what I have to do, let this be temp. So temp equal to temp next. So when 0 less than 3, 0 is less than 3, yes, temp. This will become my temp. Then 1 less than 3, yes, this will become my temp. We have to stop here. So let us write k minus 1. So you will reach here. That's it. This for loop will bring my temp to the third node from the beginning. That is the kth node from the beginning. Simply write cout temp data. Very small logic. Using for loop, you can iterate over that. This is fine. But how do I find the nth node from the end of the list? What is the logic of finding the nth node from the end of the list? Okay, so any idea how we can do this? How we can find out the nth node from the end of the list? Because I do not know what is the length of the list. Maybe I am having like this. I want the third node from the end. Third node from the end means 6. I want this 6. How do we find it out? Any guess? How can we find out the nth node from the end of the list? Just give an attempt, just think about the solution, how we can find out the nth node from the end of the list. What can be done? Yes, any guess on this? How can we find out the nth node from the end of the list? We do not know the length. See, input is always the linked list. Input is always only the linked list and a head pointer. That's it. And they are saying find out the nth list from the list. Okay. So your approach was right. You should know the length of the list. You should know the length of the list. For this, you have to traverse the entire list. After traversing entire list, you will get the length. Length is 8, for example. Okay. Then what is the n value given? That is L minus n you do. L minus n you do. So you get here 8 minus 3, that is 5. Right. So you have to print L minus n plus 1 data. Simple. So 2 times you are iterating it. What is the solution here? You are iterating it 2 times. First time you are finding out the length of the list. Second time you are subtracting and giving the list. Okay. That is the solution what we have here. Right. You will traverse the entire list and find out its length. This is one solution, no? You can traverse the entire list and find out its length. After that, this n equal to 3, right? You subtract it from the length. You subtract it from the length. That till there you iterate and print that data. Till there you iterate and print the data. Okay. So this is the no problem of finding out the nth node in a linked list from the end. You have to traverse the list, you have to find out the length, and then you find out the difference, again traverse till that point, because in a single linked list we cannot come back, we can only go forward. That is the reason you should know the length of the list. Okay. In single linked list we cannot come back. So the approach is very simple. Iterate from beginning from 1 and find out length as 5. Given n is 3, I want the third node from the end, that is I want 3. So L minus n, okay, plus 1. So this will give you 5 minus 3 plus 1. So 3, right. So that is the third node. So reach till this location and print its data. That is the third node from the end. Okay. So let's see one more interesting problem. Little interesting. Please pay attention and understand this question. We will try to implement this all. We will write code for this all. Okay. In soon we will implement them. Let's see the fourth problem here. Intersection point of a linked list. Okay. There are 2 lists L1 and L2. Assume they are meeting at a common point like this. What is that common point? We have to find it out. It means what is that data? Maybe there is some data like this 10, 20 and 30. There is 40 here. There is another list 15, 25, maybe one more number. Let me take. Here we have 5, 15 and 25, 30, 40. There are 2 lists L1, L2. Right. Both of them are meeting at a single point. This intersection point I want to find it out. What is that element in that intersection point I want to print? Okay. List size can be different. First list can be like this 1, 2, 3, 4 and they are meeting at 5 and then 6, that is null. Second list can be just 1, 2 and it is this after 2 it is meeting 5. It is meeting 5. So list 1 is 1, 2, 3, 4, 5, 6. List 2 is 1, 2, 5, 6. They both are meeting at a common point 5. I want to find out that point. How do you find out the intersection point in a linked list like this? So again, that's what I said in face-to-face interviews. Okay, not all questions are coding questions. In face-to-face interview, they ask you to write that logic. What is that code snippet? How will you solve this problem? That approach they want to know from you. to ask such kind of any interview questions. Generally, if I want to ask from interview, these are the little complex problems and interesting ones. That's why I said you should all know how to write the code on paper. You should be able to write that insertion operation. What is the logic of inserting an element at the beginning? What is the logic of inserting an element at the end? That logic, if you are writing on paper, then you can solve this. So in interview, maybe this question is given to you. On a white paper, he is drawing a list like this, asking you what is the logic. Tell me the logic to find out the intersection point. Okay. So how we solve this? Let us try to explore this also, how to find out the intersection point in a linked list. Okay. So generally, list L1 and list L2 is there. One thing, first step is to find out length of L1. You will get it as 4. Okay. Find out length of L2. You will get it as 5. Right. You will get it as 5. 1, 2, 3, 4, 5. Here it is 1, 2, 3, 4. Okay. Now you maybe let me take one more simple example before I explain this approach. So there is a list like this, 1, 2, 3, that's it, it is ending here. Okay. There is another list 5, 6, 7, it is pointing to 2. So the list is like this 1, 2, 3, that is L1, and L2 is 5, 6, 7, 2, 3. The length of this list is 3, the length of this list is 5. Okay, length of this list is 3, the length of this list is 5. Now, what is the difference between these two? What is the difference between these two? That is 2. Okay, difference between these two lists is 2. In this case, you see, when I am at 1, list L1, okay, or the list L2, you take the list L2. Okay, whichever is larger, that list you take, L2 list. L2, how many elements are there? 5. Okay, and see, again I will write here, length of L1 is 3, length of L2 is 5, because there are 3 and 5 elements. Okay, where is the merging point? Merging point is here. Merging point is here. Find out the offset difference. Find out the offset difference means generally you find out numerical difference here, that is 2. Okay, that is 2, right. So you iterate L1 is 3, this is 5, L1 is 3, this is 5, and you are having a point 2 here, right. So in this list 5, you iterate it. How long should I iterate it? You have to iterate, the difference is 2, right, the difference is 2. So maybe if you take L1, just iterate 2 points, come to the second point, that is the meeting point. In list L1, traverse 2 times, you get the list L1. Okay, let us take one more example. Let me take 1, 2, 3, 4, and it is null here. So there are 4 elements. The other list is 5, 6, 7, 8, 9, and it is merging at 3 here, and then so list becomes 1, 2, 3, 4. That is L1 is 4. The second one becomes 5, 6, 7, 8, 9, 3, 4. So this becomes L2 is 7. L2 is 7. Where is the meeting point here? Where is the meeting point? How do you find out the meeting point here? You have to find out the difference between these two lists. You have to find out the difference between both the lists. What is the offset difference here? 7 and 4 difference will be 3. 7 and 4 difference will be 3. Right. So in this case, what you have to do? 9 is pointing to 3. Okay. If you are taking largest one, you follow one approach. If you are taking smallest one, you follow some approach. If you are starting from using list 1, if you want to find out the smallest one, the difference is 3. So the third node is the meeting point. Third node is the meeting point. Okay. If you want to use L2 to tell the answer, if you want to tell the L2 as the answer, then that is at 5th node, right? It is at 5th node. So how do you find out that? From this, how can you tell that? Okay, using this numbers, what is the logic of telling that it is using that is the 6th node is the meeting point? How can we say this? Right? Any guess on this? intersection point I
Sir,
want to
the double of difference.
double of this, right? So that's what, there are multiple ways to get the intersection point of a linked list, right? I hope you understood. You list logic is very simple. 1 2 3 4 is there, and there is 5 6 7, and this is meeting here. So 1 2 3 4, the other one is 5 6 7 3 4, they are meeting at 3. This is a typical case. If you apply the logic, L1 length is 4 and L2 length is 5, difference is 1. If you move one pointer, is that the answer? No, right? If you find out the difference of L1 L2, we have reached here, is that the answer? No. Okay, when you find out the difference, that difference you subtract. L1 length minus 1 you do, L2 length minus 1 you do, right? 5 minus 1, 4 minus 1, that point is the meeting point. Again I will explain. There is a list 1, let us take some big numbers, 10, 20, 30, 40, 50 and 60. This is list 1. There is list 2, 10, maybe same numbers, no problem, that is also possible, 15, 20, 25, 30, 35. Oh, they should not be same now. We are looking for a common point. So let us take 5, 15, 25, 35, and I have 40 here, and then I have 55. That's it, is my list. Okay, so where they are meeting? They are meeting at 40 here and here, right? So you see the length of L1, it is 6, length of L2, it is also 6. When you find out difference, that one more typical case, when you find out difference, it is failing, no, we are not getting the point, difference is 0. Even if I say the approach, you do L1 length minus that 0, you will reach that point, no. Okay, so in this case what can be done here? How do you find out the intersection point? See, when we draw the list like this, let us okay. So I have 10 here, 20, 30, 40 and 50, this is null, right? Then another list is there, let us take a smaller one, 5, 15, this is pointing to this, that is it, this is pointing to this. Now see, you are reaching end of the list from both. Okay, from L1 and L2 both you can reach the end of the list. You will find out the length of both the list. Okay, you will find out the length of both the list. What is the length of the element list here? 1, 2, 3, that is 5. So in this case, I will erase this part. L1 is 5, L2 is 4. You are reaching end of the list, right? Now you take this L2, that is 4. No, L1 is large, I came to know. L1 is large, I came to know. Okay, fine. After that, you take the length of L2. You take the length of L2, that is 4. This L1 you traverse 4 times. This L1 you traverse 4 times. See, 1, 2, 3, 4. Okay, you traverse 4 times. Okay, if this node is just one node away from the null, okay, you reach here. Now the same example, 10, 20, 30, 40, 50 and 60, both length is same. Okay, 5, 15, 25, 35, here I had 40 and 50, some number 55. Okay, so the list is, they are meeting at 40, they are meeting at this 40, right? So what you have to do, you have to iterate any one list first. Length you will calculate, both you will iterate, both length you will find out, that's okay. This is 6, this is 6. Difference I found out, let the difference be 0, that's also fine. Now you traverse this list L1, you traverse this list L1, till which location you have to go? Difference 0 means from beginning only, no, there is no particular part. Suppose the difference was, suppose I'll tell you the logic. Suppose the difference was 3. Suppose the difference was 3. So then L1, you move 3 nodes. You move 3 nodes L1. Then check this element. Then check this element in this list. Find out this element in this list. So in our case, the difference is 0. 0 means you need not traverse anything. You compare this to, okay, you compare this to, you check it here, is it common, is it common, is it common. If not, again take this, check. So you have to compare both the list to find out the common element. Okay, you have to compare both the elements to find out the common element, right? So don't simply give one solution by simply, no, I gave different solutions here. Everything was satisfying for you, but it was failing. When I apply that to a typical case, it was failing. We were not reaching to this common point. Okay, right? So this is one more interesting problem. We will try to implement this. We will see the output, how to write the logic for this intersection point. So let's see one more final problem before we go and implement the programs. See here, remove duplicates from a sorted linked list. I have a sorted linked list with me, elements like this 11, 11, 11, 21, 43, 43, 60. I want to remove the repeated elements, duplicates. I want my list to be like this. How can I do here? Okay, so you have a list 11, 11, 11, 21, 43, 43, 60. This is having null, right? How do I delete? So again you take a temporary pointer temp, check temp with temp next data, temp next data. If both data are same, then what you can do, just break this connection and form a new connection like this. Just make your temp equal to temp of next. When I have to do this, when these two data are common. That is my logic here. I have to repeat this procedure always. If temp is equal to temp next. Now the list became something like this. 11 and 11. Now again, this is my temp. What is temp next? This is my temp next. If temp is equal to temp next, temp equal to temp of next. So again, this is also deleted. Now I have a link like this, 11 and 21. Again check, if temp is equal to temp next, no. Then in that case, else part you will have temp equal to temp next. So this becomes my temp and this becomes my temp next. Again check, if this is equal to this, no. Then make this as my temp, this as my temp next. Again check, is this both equal? Yes, they are equal. When they are equal, let this be my temp, let this be my temp next. So this connection I am forming. That way you are deleting the duplicate elements from the list. Logic is very simple. You are trying to find out temp, comparing temp and its temp next. If both are same, form this link. This is deleted now. Again compare temp and temp next. Are they both same? Yes. Delete this, form this link. Are they both same? No. Just move temp. So this becomes my temp and this becomes my temp next. Are they both same? No. Just move forward. Temp and temp next. Are they both same? Yes. When they are both same, break this and form this link. So this is my temp, this is my temp next. Now are they both same? Or we have reached the end anyhow, right? So we have to stop the process. Either when we reach the end or when, that is the only condition we have. Once we reach the end, we have to stop the process. So you will have a linked list with the duplicate elements deleted from a list. Like this, we have hundreds of problems in linked list. Okay, especially for placements, there are hundreds of problems. Like one of our friends were asking, how do you insert? Let us discuss that problem also. How to insert a new element in a sorted linked list. So it means I have a list like this, 3, 5, 6 and 8. This is holding my null. Now I want to add a new element. Let that new element be 4. I want to add a new element 4. I know only one pointer, no head. That is default. For any list, we know only one pointer head. What I have to do now? Check the heads data. Again I will take temporary pointer. No, I will not play with head. That is our blind rule. What is that rule? Blind rule, always don't play with head. Take a temporary pointer t. Check if this t's data if it is t's data, no, if it is less than this new nodes data or the element which I want to insert, if that is less than new nodes data, do temp next, bring your temp here.
Sir, your voice is breaking.
Okay, is it audible now? Am I clear? Okay, am I audible now?
Yes, sir.
Okay, see, the logic is the new nodes data is 4, temp's data is 1. Check if temp data is less than new node data. If this is the condition, then move your temp to temp next. Move your temp to temp next, right? That is not the case. You have to check 2 times. What you have to do? Check temp data and new nodes data. If this is less than this, and temp next data and the new nodes data. If it is greater than that, okay, you understand my point here. You are comparing this 1 with 4, 3 with 4. Is 1 less than 3 and is 3 greater than 4? Then you have to insert it here in the middle. If any one of them is failing, just move your temp to the next node. So your temp is here now. Again check, is 3 less than 4 and 5 greater than 4. If this is true, then insert the element here. So like this you can bring the element here in the, you know how to insert an element at any given location. Given a temporary pointer, you know how to insert a new element in the middle of the list. Okay, so if it is a sorted list, you have to write a if condition like this. If temp's data is less than new nodes data and temp next data is greater than new nodes data. In that case, if that is the case, you have to insert after temp. So you have a temp pointer, you have to insert it in the middle. You have to insert it in the after temp, you have to insert it. So you have reached your position. You know how to insert at a given position. That is the logic. Okay. So inserting an element in a sorted linked list, right? So like this we have so many applications or programs or problems in linked list, right? Very useful for your placements. We will try to see the implementation part. So with this we complete the discussion of the problems. We will see the implementation.